Okay, for the second video, okay, we're going to look at solids of revolution, okay, and then we're also going to look at how we find the centre of mass of a solid, okay, and from a certain plane and things like that, okay. So the first bit, okay, is solids of revolution, okay. So centre of mass, okay, we've got two kind of variations to this, and it basically depends whether we rotate our curve around the x-axis, okay, so vertically, or if we rotate it around the y-axis, okay. Now, it can be different for different questions, okay? If it's a prove question, so like prove that this is the formula or something like that, okay, then we can just, it doesn't matter which one we use, we should end up with the same answer, okay? It just depends on how we're going to rearrange, okay? So these are two formulas at the top, okay? Now, notice we're going to have because we're dealing with three-dimensional shapes, we're going to have three dimensions in terms of my x bar and y bar, and now we're going to have our z bar as well. Okay, so you notice both these, my z bars are 0, okay? We don't really think about that as such. We only think about going around the x-axis or the y-axis, okay? So the centre of mass, okay, of a uniform solid, if the curve is y equals and a function of x, the first one, the red one, complete around the x-axis, so vertically down, then we get something that looks like this. So y bar is 0 and z bar is 0 because it's on the x-axis, so my y is 0. Now, to find my x bar, we use this equation here, okay? So we're still using integration. Okay, so pretty much, if I just go back up, near identical to what this one was. Okay, the only difference is now it's got squares in it. Okay, now it's got squares in it simply because you're dealing with like a 3D shape now, not just a 2D. Okay, whereas before it was just a 2D laminar. Okay, and now the centre of mass for the green one, okay, is very, very similar. This is if it's x equals a function, okay, and then you do your rotation around the y-axis, so horizontally. Okay, and you've got these very similar equations here, apart from where the squares land and then the denominator changes. Okay, so these are two that we need to know as well. Okay, not on form booklet. Okay, so part A, for this an example, we need to prove, okay, so this is when we got to prove that question, that the centre of mass for a uniform solid hemisphere of radius r is 3r over 8 from the centre of the plane of the hemisphere. Okay, so let's think about what's going to create a hemisphere. Okay, if I draw my set of axes, if I had a quarter circle like this, okay, and it's got a radius of r, then if I rotate that either in the across the y-axis or vertically across the x-axis, okay, then that'll make me a hemisphere if I rotate it one full turn, so a full 2 pi all the way around, okay. So I know I'm dealing with a circle. Now the equation for this, okay, is going to have to be like it is for a normal circle, which would be x squared plus y squared should be my radius squared. Okay, now it doesn't matter how I rearrange this. I can either make it x equals and then I'm going to use the green one, or I can make it y equals and I'm going to use the red one. Okay, so I'm going to use the red one. I'm going to rearrange it so it's y equals. So I've got y squared is r squared minus x squared. Now, normally I'd go, okay, let's square root it. So I'll do this in red because I'm not actually going to use this value when I use it, okay? So normally I'd go, okay, let's square root, and we got y equals the square root of r squared minus x squared. However, if we look at the red equation up here, there's only y squareds involved. So I'm only going to square it anyway and get rid of the square root. So that's the last blue one there is what I'm going to use during this question, okay? So now, if I'm using the red equation, I need to know these two bits. So I need to know integrate between a and b of y squared and integrate between a and b of x y squared, okay? So let's do the bottom one, it's a little bit easier. So integrating of a, b, and I'm doing it for y squared dx. So y squared is r squared minus x squared. Now I've got to think about what limits I want to put in here. Now let's think about what this circle goes between. It goes between 0 and r in my x-coordinate, so 0 and r. Okay. And now let's plug everything in. So we're going to integrate it first. So it goes to goes to r squared x and then minus x cubed all over 3, and that's going to be between 0 and r. And I plug in r, and I'm going to get 2/3 r cubed overall. Okay, so that's my first part. And then very similar for the next one, I'm going to do it between 0 and r, but this time I want x, y squared, so it's going to be x and then y squared. So times everything by x, so I've got r squared x minus x cubed. Okay, if I times everything by an x, integrate like normal again. So I've got r squared x squared over 2. Remember, r is just a constant, so let's just leave it floating about. Okay, minus x to the power 4 all over 4 between 0 and r. So when I substitute 0, everything's going to disappear, so I just need to substitute r in. It's going to give me a quarter r to the power of 4. Okay, and the final bit is I'm just going to plug in my calculator into my formula. So x bar is simply this bottom one, so a quarter r to the power of 4 all over the bottom one, so 2/3 r cubed, and then we can simplify from there. So r is going to cancel, so I'm left with r on the top. 3 comes up, 4 comes down, so I end up with 3/8 as required. Okay, now as I said, if you did it with the green formula and said you had y bar equals, okay, you should have ended up with the same answer. Okay, you would have rearranged this top equation so it was x squared equals, and you've got r squared minus y squared. Okay, and then you would have plugged it in, you would have integrated like you did the previous one, you would have plugged it in, you end up with the same answer. So it doesn't matter which way round you do it, okay, as long as we pick from there. Now, this came up, where was it? The 2019 look. Very similar, and then you had to use it in the next one for it, okay? So very similar for this one, we're going to have to use it in this next part. Let's see what's going on with it. We've got a wooden mushroom consists of a cylinder of radius A and height of 12A, surmounted by a hemisphere with radius 5A. Okay, so let's think about, I've got my cylinder, and then I've got my hemisphere, which rubbish drawing of a hemisphere on top. Okay, the center of the top of the cylinder is at the same as the center of the hemisphere, so they're perfectly lined up. Find the height of the mushroom center of height, okay, compared to the plane. So this bit at the bottom that's kind of like sitting on, okay, let's call that the plane, the bottom. Okay, I'm going to get rid of it so you can see my writing a bit more clearly. Okay. That's better. Okay, so let's label some things on. So first of all, the hemisphere has a radius of 5a. Okay, this has a radius of a and it has a height of 12a. Okay, now there's nothing saying about the densities being any different to each other or anything like that. So I'm just going to go with the standard. Let's do the let sigma be the density. Okay, and I could do the norm thing. If one was like double it, I could choose two sigma and all that kind of thing. Okay, so we got two shapes here. Okay, we got a cylinder, and we have our hemisphere, and then we have the whole shape for the mushroom, which we're going to add these two things together. So I'm going to put a little plus next to it. Okay. Now the first one is going to be my mass. So this should be my volume times my density. So let's start with the cylinder first. I need the volume of this cylinder. So I'm going to have pi r squared, so pi a squared, times by 12a, times by sigma, okay? Which is going to come out as 12a cubed pi sigma. Okay, quite a nice number. Okay, then let's do the same for the hemisphere. So first of all, it's hemisphere, so it's going to be half a full sphere. And then a sphere is going to be 4/3 pi times by my radius cubed times by sigma. Okay, so I'm going to quickly type in all my numbers in my calculator. Okay, so I've got a half times 4/3 times by 5 cubed in this case is going to give me 250 over 3 a cubed pi sigma. Now you'll notice they both have that a cubed pi sigma. So when I put all these together now for the final bit, okay, well, let me change color. So the whole mushroom is going to be adding these two. Okay, so I'm going to do 12 plus 250 over 3 is going to give me 286 over 3. So I've got 286 over 3 a cubed pi sigma. Okay, and now let's do the next column. Okay, so the next column, is going to be my distance from the plane. So distance from plane, or we can just say height as well. It's the other thing that I'm looking at. Okay, now the cylinder should be nice and easy. It's simply just going to be halfway up the cylinder, so it's going to be 6a. Okay, now for the hemisphere, I've already gone up 12a for the to get up to the hemisphere. And now I need to know how much the height is from here, and we're going to use this formula from over here. So it's 3/8 of r. So I've got 3/8 times by 5a. Okay, which again I can just simplify very quickly. So I've got 12 plus 3/8 times 5 is going to give me 111 over 8a. Okay, and then down here, this is going to be my height that I want, or my h bar, or you could do your y bar. Okay, it doesn't really matter. Okay, now what I'm going to do with this one is very similar to what we did to the laminas in the previous section, where I'm going to now think about, okay, let's take moments, and my moments for my whole shape should equal my moments for like each individual like section. So my moments for my whole mushroom, so these two times each other, should be the cylinder, the moments for the cylinder adds the whole moments for the hemisphere. Okay, so I'm going to do moments about the plane. Okay, so my mushroom is going to be 286 over 3 a cubed pi sigma times by my h bar. Okay, and that's going to equal these two things I'm showing. So the first one's going to be 12 a cubed pi sigma times by 6a. Then I'm going to add, because I added these two shapes together. Remember, if you take them away, you still need to take away instead. 250 over 3 a cubed pi sigma times by 111 over 8a. Okay, I'm simply going to simplify this down a little bit. Okay, so when it starts working again, there we go. Okay, so first of all, sigmas, we know that this happens, gets rid of them. Then they've all got an a cubed in it, but remember this left-hand side still has at least one a in it, that's fine. They all also have a pi in it, so I can get rid of the pi's. Okay, so I'm left with a lot easier of a thing for me to deal with and write down. Okay, so I'm going to simplify I've got 286 over 3 and then my h bar, and on this side I've got 12 times 6a plus 250 over 3 times 11 over 8. Sorry, 111 over 8a. It's not going to give me a nice number, but I end up with 4913 over 4a. So my h bar is going to be times by 3 divided by 286. Comes out as 12.88a. Okay, and that would be my height from the of the center of mass on this shape. Okay, now we basically assume that like the center is kind of like its y-axis, so its x bar would be 0. Technically, I could have called this as y bar. It's fine. It's just it mentioned the word height. That's why I called it its h bar. Okay. Now, if you look at the question that has come up before, there's a very, very similar kind of style of question. The first one was integration, show that this is the rule. Okay. Now, you can have to prove other things, kind of like cones and stuff like that. Okay, so think about a cone would be you have an equation for a straight line, and then it either rotates around the x-axis or it rotates around the y-axis. Okay, very similar kind of thinking. Use these formulas up here after that. Okay, now for this bottom one, okay, it was slightly different because first of all, the shape is slightly different. It's not like a mushroom. Okay, it's this shape here. It's made of this, but however, the density of the hemisphere is 50% more, so it's 1.5 times. Now, the key bit on this one, when you have a go at it, okay, is that people forget that if this is the radius of the cylinder of the circle on the bottom, it's the radius of this cylinder, so that's r, which means this height must be 2r. Okay, little things like that often throw quite a lot of people off. Okay, And then we do the similar kind of thing as you can kind of see the answer here. Do our masses of each, add them on, then take moments. So your total moments should equal the moments of these two added together. Okay, and there's still an R in my answer, which is completely fine. Okay, same as I had here, I had an A in my answer. Okay, and now they could just give you ones with loads of numbers, and then it'd be nice and easy for us to work out. Okay, now if you scroll down as well, there are loads and loads of different questions and the mark schemes. Okay, so you can have a go at some of those. Okay, some of these are really difficult. Okay, so make sure you have a go at them. Okay, and try and master them the best you can. Okay, apart from that, I'll see you in the next section.